Welcome to Knowledge on the Go, the podcast brought to you by the PI Collaboratives team at Vizient. I'm Heather Ramirez, Performance Improvement Program Director here at Vizient, and your host for this podcast. Today we are discussing the use of artificial intelligence, or AI, for stroke detection, triage, and notification. As some of you might know, acute stroke is a highly prevalent and costly condition. On average, in the United States, a stroke occurs every 40 seconds, and a stroke-related death occurs every 4 minutes. Overall, this makes for about 800,000 cases of stroke each year, with the total direct and indirect cost estimated to be more than $34 billion annually. Because of the poor outcomes and high costs associated with acute stroke, any effective new technology we can use has the potential to be a very high impact. To that end, I would like to introduce our Vizient PI Collaboratives innovation and technology expert, Joe Cummings, and get his take on the rapid emergence and disruption caused by AI as it transforms a lot of the things we do in healthcare. Today, we'll focus on AI as it is used to improve the hospital workflow and the care delivered in acute stroke. Welcome, Dr. Cummings. Let's start at the beginning. How can you define AI for us?
Well, first off, thanks for having me today, Heather. AI is really just an all-encompassing term that's used to describe when you use computers and software to do things that humans do through higher reasoning, like learning or problem solving or pattern recognition. But if you drill down into it a little, there are lots of subsets and subtypes of AI that you might have heard of. These include types of AI like machine learning, neural networks, and deep learning. These are all just more specific forms of AI, and sometimes they're all just lumped together and identified using the umbrella term of AI. But it's the deep learning type of AI that's probably the one to really pay attention to these days. Deep learning just refers to a specific type of programming architecture. It uses neural networks for the model, and within the neural net, there are a bunch of these hidden or deep, hence the name, programming layers that may be designed to detect different features of the problem, and then these deep layers are all linked together. But the deep learning type of AI has really become the predominant one in most emerging medical devices now, and also in stroke. And that's for good reason, because deep learning's been shown to really have some significant leaps forward in terms of learning capabilities and in their accuracy, especially for tasks like image recognition.
Wow, there are so many different types and forms out there. So with so much emphasis on stroke, can you help us understand why AI is being used for acute stroke?
A couple of reasons. One, the CT scan is the primary tool for diagnosing acute stroke. And as I just mentioned, I think the deep learning algorithms are really well suited to read and interpret a CT image. The other reason, and probably more importantly, is that time is brain in acute stroke, meaning that neurons are literally dying every second until the cause of stroke is resolved. So one of the big advantages of AI is speed compared to humans. So the AI-based algorithm has the potential to speed up some of the steps in the stroke process, like the initial diagnosis, for example, and then also reduce some of the other delays that can be inherent in the process.
Yeah, time is so critical to delivering effective care for stroke patients, and we oftentimes know that this is a huge barrier for members. When we're talking about the benefits of using AI to improve clinical care pathways and certain clinical processes, can these applications be used for ischemic and hemorrhagic stroke?
Yeah, there are actually FDA-cleared AI platforms for both of these types of stroke. But I'd say one of the first and most successful of the AI platforms is for a particularly bad kind of ischemic stroke. It's called an intracranial large vessel occlusion, or an LVO. So these strokes involve these large vessels that feed large brain areas. So when they get blocked, they're associated with rather large infarcts. And that means some very poor outcomes in terms of patient morbidity and mortality. But the good news is that in an LVO stroke, you might be able to use an interventional procedure called a mechanical thrombectomy, where you go in with a catheter and pull the clot out and restore the brain perfusion. But again, the faster you can identify and treat these patients with thrombectomy, the better. And that's where the AI comes in.
So the direct impact AI can have on timing is not just critical upstream, but also downstream in terms of treating and managing patients. So really having positive impacts in efficiencies and transitions of care for stroke patients. Can you expand a little bit more on how AI can result in time savings?
As you know from your stroke collaborative projects, workflow delays can occur for very many reasons. But in this case, one of the potential sources of delay can be the time it takes for the radiologist to read and then report on the findings from that initial CT scan. So for example, the radiologist may be dealing with other cases, or it might be off hours and they have to be tracked down. And then just compiling and reading all of the CT data takes some time too. So all of this together can result in some long delays until the stroke diagnosis is made. In the AI workflow, the CT scan is immediately pushed up to the cloud, and there it's automatically analyzed by the AI algorithm. And of course, the AI is available 24/7. But the AI analysis usually only takes about 5 minutes or less, and after that, you have a diagnosis. That's typically much faster than the radiologist. The next thing that you need to do is notify multiple people to tell them, hey, there's a patient down in the ED right now with a potentially treatable stroke. So the AI platforms all come with this built-in notification function where immediately after it makes that rapid stroke diagnosis, it automatically pushes these notifications out to a local user list. And they can use mobile phone alerts or emails or texts. And the notifications also usually include a compressed CT image that you can look at right there on your smartphone. So theoretically, in some cases, the interventionalist could get the AI diagnosis and the notification, evaluate the LVO image right there on their mobile phone, and then begin booking the thrombectomy procedure. And that's even before the initial diagnosis is confirmed by the radiologist. That's how fast it could be.
These use cases are really fascinating, and I think you've painted a really clear picture of how AI can positively disrupt and redesign care beyond traditional care settings to really get at improving access and clinical outcomes. So when using these AI-based workflows, how much time can you actually save?
The comparative time savings are really going to be dependent on each hospital's specific circumstances and their local practices. But there are a number of before and after type studies in the clinical literature that shows at least 15 to 30-minute improvements or more, with a lot less variability in these times. And this is for metrics like, say, the door-in to neuroendovascular team notification. This can also have some cascading time effects with significant improvements in the other stroke workflow time metrics as well.
So I know there are so many AI applications, platforms, products out in the market that are looking to improve detection, triage, and notification. Specific to LVO stroke, how long have these products been around?
At last count, I identified 5 different AI products for LVO stroke that had an FDA clearance. It's interesting because you can rapidly get multiple competitive products in an AI type of field. So unlike some of your more traditional medical devices, the bar is a lot lower here because you don't have to have a factory or anything to produce a material product. You really just need a few coders, some high-end computers, and a good training data set, and you can produce an AI product. The first product of this kind for LVO was from a company called Viz.ai. They got their initial FDA clearance through the de novo approval process, and that was back in 2018. So they've been around for about 3 years now. After they got approval, all the other companies were able to use them as a predicate and then get their clearance through the 510K process. And some of these are newer and now just rolling out their marketing efforts.
So with all this activity and disruption occurring in the marketplace, how are hospitals responding to this innovation and new technology? What's the uptake like among hospitals?
I'd say very typical of a newly emerging innovative technology. It was pretty slow at first. But then there was this huge milestone. CMS established a reimbursement policy for the technology through its new tech add-on payment program. That's a really noteworthy accomplishment because this was really one of the very first AI applications to get a direct reimbursement decision. The only other AI app that I know of with direct reimbursement is AI used for detection of diabetic retinopathy. But after it got the CMS reimbursement, and that was in October of 2020, the technology took off pretty rapidly. And I was interested, so in order to see how many hospitals were using it now, I had an analysis done recently using the Vizient clinical database. And that data showed that 63 Vizient CDB members had used the billing code for this technology in the last quarter of 2020 when it first gained reimbursement. And then when I looked 6 months later, the number of hospitals using the technology had more than doubled up to 130. So in total, if you look nationwide, there are now thousands of stroke CT scans being analyzed by AI every week. So I'd say this is a real success story in terms of AI with a lot of uptake by hospitals.
I'm going to echo that this is great success. I mean, we know that reimbursement is a big barrier for organizations to adopt and scale virtual health solutions. So it's really interesting that this was one of the first AI applications to get direct reimbursement. But what about CMS? How does CMS reimbursement work?
Under the new tech add-on payment rules, CMS reimburses up to about $1,040 per use for the cost of the technology. It gets a little bit complicated in that this payment doesn't necessarily apply to every patient that you use it on. But in some hospitals with a medium to heavy caseload of stroke patients, they can typically get more than $100,000 in additional reimbursement in a year for using this technology.
So let's shift gears to clinical evidence. How does clinical evidence support this technology? What does it look like?
Right now, there are multiple clinical studies out there that have reported some pretty good diagnostic accuracy with sensitivities and specificities on the order of 95% or so. They've also typically shown a very high negative predictive value, and that's clinically important because that means you can confidently rule out a potentially treatable stroke. The trade-off with that, of course, is a certain amount of false positives, and when you get too many false positives, you can have an alarm fatigue from all these urgent notifications for all these patients who won't actually go on to be scheduled for an interventional procedure. But overall, the current evidence provides a pretty strong proof of concept basis for using AI in the management of stroke. Plus, the way that these things are labeled is for use in addition to the parallel conventional review process that's done by the human radiologist. So by using the parallel process, it really helps to ensure safety.
Joe, you've done a really great job helping us understand how certain AI technologies can be a high impact application for detecting LVO stroke. What other applications in development for AI should we be aware of?
There is a lot going on in this field. There are literally dozens of companies worldwide, and they're developing all kinds of different AI-based stroke apps. The hemorrhagic stroke detection and notification app that we talked about earlier, it's a pretty high growth area right now with a lot of companies involved. And then there are a number of other AI tools that include algorithms that can automatically locate and outline disease segments on different types of scans. They can calculate the involved core and penumbra infarct volumes and then use this to predict treatment outcomes. They can automate various stroke classification algorithms like the aspect score. And overall, they just can facilitate the use of more advanced imaging modalities and techniques. So because of all this, I really think that the neuroradiology department of the future is in for a lot of change. I think they may have a whole suite of these commercially available AI-based apps for detection and interpretation and workflow-related functions in the near future now.
This is so interesting. I mean, you have me convinced that AI in medicine is here to stay. What do you think?
I would say so. I think AI is going to disrupt and transform a lot of the current processes and procedures that are currently used in hospitals. The image-intensive fields, in particular, like radiology and to a lesser extent, pathology and dermatology and ophthalmology, they're already seeing a lot of these AI-based apps. I also think that hospitals need to be ready for this AI revolution. So I think they should be actively involved right now in learning about the technology that's out there, the applications, the clinical evidence and economics. And even where appropriate, they should probably be proactively implementing these technologies right now at their hospital.
I agree, Joe. The evolution of AI and how it's transforming healthcare is really exciting. I, for one, am going to start following AI more closely in the future. Thanks again to Dr. Joe Cummings for speaking with us today and to you for listening. For Vizient's PI Collaboratives team, I'm Heather Ramirez. Please join us for more knowledge on the go. Subscribe today, like us, or send us your comments at picollaboratives@vizientinc.com.